In particular, we will be focusing on the Isernia project. Isernia is a municipality of the city center of Italy that asked us to implement a DRT system. So in order to do that, we decided to use PTV Visum, and I will show you how. So this is the agenda for today. First, we will see what is the demand responsive transit. Then I will give you an overview of the study area. So I will show you what was the study area of the project and its characteristics. Then we will talk about some preliminary analysis that are mandatory to be done in order to work then with a model that can represent properly a DRT system. And finally, we'll go into the core of the presentation that is made by the model building in PTV Visum and the results analysis in PTV Visum. And finally, we will have some minutes for eventual questions and answers. So let's start to see what is a demand responsive transit. So demand responsive transit is basically an alternative to the classical frequency-based or schedule-based public transport. And it consists in a shared service in which the user can choose where to pick up the bus and at what time to pick up the bus and, of course, its destination. So in this slide, it's represented in a schematic way how the DRT works. So let's suppose that the man with the stroller on the left side want to reach the recreation park, and he does want to do that with the DRT service. So he just use the app where the DRT app, so the service for the demand responsive transit, the app asks him where does he want to go and when does want to go. So once he chooses his preferences, then the app suggests the nearest stop point, and the bus take him and carry him to the final destination. But it's very important to underline the route of the bus, because actually the DRT system does not work as a user optimum, but it works as a system optimum. That means that if there are any other calls in that time window that wants to take the bus, these calls must be taken. So the path of the bus is not the shortest path, but it is the best path for the system. So the path that reduces the cost of the system. And as you can see here, for example, if there is a lady wanting to take the bus along the route, the bus can make a deviation and then reach the final destination for both the man and the lady. There are several typologies of shared taxi, of DRT. In this slide, I just wanted to mention the most common ones that are the shared taxi and the dial ride. They both are dial based and are stop and they have stop on requests. But as you can see from the service configuration, they are quite different, because the shared taxi actually shared taxi services have always a main point where the service starts or finish, and there is a predefined route to this main point. So actually you can choose a point on these routes that is nearest, the nearest one to your delivery point that is your house. This usually is used for big offices or for touristic points such as Niagara Falls or a railway station or airports. The dial-a-ride is we can say the most common one, and in fact really often dial-a-ride and DRT seems the same thing. In the dial-a-ride, the route is flexible, and as you can see in the last point, it might be either stop to stop or point to point. There are some services, for example, the one for person with physical difficulties that are point to point, so they bring you home. But generally, for the public transport, we use a stop-to-stop service. So, as I show you in the slide before, you reach the nearest stop point that is suggested by the app service. So you can reach the destination with a route that optimizes the system, so that takes all the people that are reaching the same areas, the same area. And as you can see, this service is mainly for young people, so people under 18 without a driver license, or people over 65 or low-income people. And this is exactly the service that the municipality of Isernia asked us to implement. Let's see now the overview of the study area. So, as I told you, the study area consists in 3 municipalities. The main one and the bigger one is the one of Isernia, and then there are the neighboring municipalities of Miranda and Pesche that actually are 2 small villages. I just want to give you really a quick context, because later on in the model we are going to see to explain some things that are related to the territory. So just want to really give you some the main information about the study area. So let's start from Isernia. Isernia has a population of 22,000 people, an area of 69 square kilometers, and an elevation that goes from about 300 to 900 meters above sea level. And very important, as you can also see on the map, where you can see several labels, small labels. These are the hamlets. So there are 23 hamlets that counts from about 100 people to 600 people. And so putting this information together, the ones that you can see in this slide, you can see how difficult it is to run a standard frequency-based service or schedule-based service with profit, because the area is very wide, and because it's very difficult to fill a bus with such this distribution of hamlets on the territory. And that's the reason why the municipalities asked us to implement a DRT service, because they wanted to run a service with more profit respect to the one that is currently running. Let's see the other 2 municipalities. Actually, Miranda and Pesche are very small villages, as you can see from the number of population. Miranda has 1,000 people, a small area of 22 square kilometer, and an elevation that goes from 470 to 860 meters above sea level. It's important to underline that the distance from Isernia is about 9 kilometers, and that there is an industrial hub that is actually on the border between Miranda and Isernia that counts 300 employees. So it's really a very important point. There are offices, there are schools, so it was very important for our analysis. And there is then finally Pesche. The population of Pesche is about 1,500 people. The area is 13 square kilometers, and the elevation goes from 400 and 700 meters above sea level. In this case, it's important to underline that the population is growing during the last, has been growing during the last 20 years, because the houses in Pesche were cheaper, and there is a lot of nature. So actually Pesche is sort of becoming a suburb of Isernia, and that's the reason why it was very important to include also this area in the project. To just give you finally an overview of the study area, let's see the population density. So you can see again the concept I explained you before. So there are several red spots that are the hamlets. There is the main one that is the one of Isernia in the center. But there are several red spots that are the ones that are difficult to reach, because usually the road for the hamlets are very difficult roads, are winding roads. So it's nearly really impossible to run a standard public transport service with profit in this area. Okay, now let's start to move on what we have done and what usually you have to do to define a DRT, to project and to implement a model with a DRT system. So first of all, you have to decide how many buses you want to use for your system. If you call a DRT service provider, the first question is how many buses you want to run for the system. In our case, there was a sort of indecision between 2 and 3, but that's where Visum helps. So we decided to start with 2. Then we did some simulations, and actually there were about the 7% of people that they were not able to take the service. So we decided to go with 3 finally. So Visum helps in this decision. Then I will show you how. Of course, in the beginning, you can just suppose about looking at the characteristics of your area. Then with the model, you can see if your assumption was correct or not. In this case, so as I told you, we went before with 2, then we went with 3. And of course, for each bus, you have to define an area of competence. So if the calls come from this area, then is a given bus that takes these calls. So there is the area, the blue area for the bus 1, the red area for the bus 2, and the green area for the bus 3. And then there is basically the city center in yellow, that is a sort of intersection of the 3 areas. As a consequence, then you have to decide the holding area for the bus. So this is a very crucial operation, because you have to define a point that can easily reach the points of the area that point was assigned to. So this is the configuration of our holding areas, and this is done looking at matrices and socioeconomic data. So you just have to map into it's a GIS analysis in the end. You just have to map into your Visum file the socioeconomic data and try to understand which are the points that are supposed to call the most of the demand with respect to the others. And then finally, the definition of the PUDO. I want to call them PUDO because I will use this definition in the next minutes many times. So PUDO stands for pick up and drop off points. It's very common in the DRT studies. So DRT service can be run either with the whole set of stop points or with just a subset of stop for the people that want to take the service. In this particular case, we decided to select a subset of stop point for basically two reasons. The first one is that we want to give the DRT service to an app that aggregates the requests. And the second one is that we noticed with some on-field studies that were some stops that were not used at all. So we didn't want to mess up the simulation with the useless stop point. So in the end, we just select a subset of stop points. So in red in this slide, you can see all the public transfer stops, and in blue, the PUDOs, but we are going to do that together. That was the really quick overview. Now I want to go into the core of the presentation, that is the Visum model building. So let's move on with the exercise. Okay. If there is any problem in visualizing Visum, just please interrupt me and let me know. So this is the model from a map. It's very important to say that there are no particular operation to start working with DRT, if not control the free flow speed, very important first, and the transport system set. These two are very important. You don't even need to check capacity if you just simulate DRT. Of course, if you simulate other minimum transport, yes, but in this case, you don't need it. So once you check the transport system set are correct for all the elements of the network, as we did in this case, and the free flow speed are correct, you can start your operation. So we can start defining the transport system for the service. So you need two transport systems. The first one is for the bus that will be allocated to the service. So we can define a minibus that will be of type private. So let's keep it private. And I want to open all the links to minibus that are already open to auto, that is car. And let's create automatically mode and demand segment named minibus. Please, let's remember this step because later on it's very important. Because once might ask why I need the demand segment if there will be probably a demand segment for DRT, but there is a specific step where this demand segment minibus is needed. And the second one, so we need two transport system, is for people taking the bus that is named DRT. Better, I named DRT, you can call it whatever you want. And this one is a PUT work system because a DRT transfer is made by two legs. A work legs to the stop points and the minibus leg. And if we want to be very precise, there is also the third leg that is the working leg destination stop to destination point. So you need to work to the stop point to take the bus. I want to open it for, I don't want to open it for all the PUT mode, but I want to create another mode that it's named DRT. Yes, this one. And also the demand segment. So we have basically did the same operation that we have done for the minibus. So we have created two lines, two demand segment, DRT and minibus, each one of them having a DRT mode and a minibus mode, and a DRT transport system and a minibus transport system. Okay, once we have defined the two transport system, so again, think about the legs. The reason why we need two transport systems is that we have three legs: work, minibus, work. That's the reason why we need two transport systems. Now we have to allocate the metrics to the transport system. There is already a matrix that has been calculated from on-field surveys. So I just have to allocate this matrix to the DRT demand segment, as we usually do for all the Visum model. And now we can go defining the PUDOs. As I told you, here in red you can see the stop points of the network. You could even use all of them. I explained you before why the reason why I want to use just a subset of stop points. So to do that, you need user-defined attributes. The reason why I want to do that together with you, I mean, probably every one of you that is familiar with the Visum knows built thousands of user-defined attributes. But when we talk about DRT simulation, all the user-defined attributes are nodes-based. So every time, basically everything is a user-defined attributes for nodes, everything. So we will do it twice just because I wanted to let you see that everything you define is just a user-defined attributes for nodes. So here we can define the user-defined attributes for PUDO. That is an integer, but you can also define as a Boolean. It's just 0 and 1. 0 not a PUDO, 1 is a PUDO. And I have already an attribute file ready for you. Of course, I don't want to do it manually with the PUDOs on the network. Let's see if it was created. Okay, perfect. But just because I deleted some line roots that were not important for this exercise. So in blue, you can see the PUDOs. And you can see we have 33 PUDOs and 78 stop points. So about half, less than a half of the stop points. Okay, once we have defined the PUDO, so the PUDO are the points that we will be used for the pickup and drop-off points of users on the network. Let's now define the holding area. So basically doing what I just show you in the slides. So let's now define the holding area. Also in this case, nothing new. You have to define a user-defined attribute for nodes, and I have the name in Italian in the attribute file. So I call it area di attesa, that stands for holding area. And also in this case, it's just an integer. So it's either 0 or 1. 1, yes, is an holding area. 0, no, is not an holding area. And switch off the background map. In this case, I want to do it manually because there are just 3 of them, and I have already UDA here in the quick view. So you just need to press 1 here and this one. Then it's an holding area. Of course, remember these steps because later on Visum will ask us, how can I understand which are the PUDOs? And we have to say, these nodes are the PUDOs. How can I recognize an holding areas? And we have to say these ones are the holding areas. So of course, it's not sufficient to just invent a name and put the attribute as one, and then everything is done. Then later on, we have to set the proper attribute to read the correct UDA. And the terminal bus is the final one. So we have defined the holding area points. Yeah, I have also a layout file. And here you can see the three holding areas for bus I just defined. So we have now aligned the system to the preliminary operation we have seen in the slides. Let's now move on to a very important steps, that is the creation of the demand. So usually everyone that is familiar with model has to forget how usually demand works with zones, and because usually, you know, demand propagate from centroids to connectors and then to downstream nodes. The demand for the DRT services works differently, and the reason is that the DRT service, as I showed you in the slide before, might be a point-to-point service. So the demand is directly loaded from nodes. So we need to define an allocation to understand an allocation to from zone to node. So we have to find a connection between zone and node. You can do it with an intersect. You can directly do it with a procedure we will see later. Or in our case, again, I wanted to do it for the third time just to really give you the idea that everything in the DRT simulation is node-based. So I create an attribute that is named node to zone. And this one is a TXT, because there are some nodes that are allocated to more than one node. So there are some nodes having 2000, 1000. Okay, and also for this, I have the attribute file. And so, for example, I can see if I click on the main instance and I want to add the attribute just to see everything was correct, you can see that there is a number in the node to zone. So that means that the demand from the zone station will be allocated to this node. Let's now we will I want to move on the procedures to simulate the DRT, but this concept of the correlation between demand and nodes will come back in a few minutes. So it's something like I want to hold on for a minute on this topic, but I will come back to make it clearer. So let's open the procedure sequence. And let's create the two procedures that are necessary to simulate a DRT system, that are the trip request and the tour planning. So in order to simulate the DRT service, you need these two procedures. What they are useful for? The tour planning is the simulation. So it's like an assignment. So it simulates the dispatch of bus on the network to carry people from their origin to their destination. The generate trip request, as the name says, it generates the trip request for the system, and we can imagine it as a sort of simulation of the database of a DRT service. So a DRT service collects all the requests from users, and then finally, so you have a list of requests containing information about the desired departure time, the desired node departure node, and the desired destination. So you are basically generating this list of trip requests. You have to allocate the demand segment to the procedure, and then we can open the procedure. There are some really few parameters on this trip request. It's very generate trip request. It's very easy. In here, you have to select the time interval where you want to apply to your system to work with a DRT service. So it can work between 10 and 8 p.m. because this was the time the DRT service is supposed to work in Isernia. Actually, they asked us to shut down the service in the peak hour at 1 p.m. because that is school time. But in this webinar, for the sake of simplicity, we'll just go on with a unique time interval. Otherwise, it's very easy. You have to create two procedures, one for the time interval of the morning and one for the time interval of the afternoon. Then you have these two windows. With the first one, you define the distribution of the number of passengers traveling together. That means that, for example, if I select these shares, I have that the 20% of trip requests are related to one passenger. The 50% of trip requests are for two passengers. So there are two passengers together asking to start at the same point and having the same destination. The 30% is for three passengers. So there are three passengers asking to go together from the same point at the same time to the same destination. For the project, we have 10 and 65. So these were the shares of the project of Isernia. And how we calculate this number, we had a long period of surveys before starting modeling. And so we tried to understand the value of this number from the surveys, basically. That there's no other way, either the surveys or you run the service and you see the weights of into the trip requests. There's no other way. Then there is this distribution of the pre-booking time. That means when the trip request enters the system. So here you can create several intervals, and you can select, for example, 5, as we did in the project. 35. That means that the 5% of trip requests comes in an interval that goes from 0 to 30 minutes before the desired time. So let's suppose we want to start our trip at 4 p.m. 5% of the requests enter the system between 4 p.m. and 3:30. 15% between 3 and 3:30. 45% between 2:30 and 3, and so on. So it's just a distribution of the pre-booking time into the trip request. And there is the random seed to apply some stochasticity, both in spatial direction and in time direction. So I will strongly suggest to use different random seeds to generate different trip requests and verify that the system reacts well to all the random seed you want to simulate, to verify. And then, as I promised, I want to come back to the allocation to node to zone. So as I told you, for the DRT, the demand is not generated from zones, but it's generated from node. And here you have to decide how you want to allocate the nodes to zones. So you can allocate the the nodes with an active connector. So if you have defined connectors, you can decide to use the nodes in the zone polygon. And here you can decide to use an user-defined attributes where you have this information. So there is an user-defined attributes where you can read where what zone the node is allocated to. So you can select the node to zone as we did before. Here, okay, it's 10 to 20, perfect. Okay, and now we can press OK and see what happens. Okay, the simulation, the procedure runs successfully. To see the output of the procedure, you have to go on list of the demand and trip requests. And as you can see here, I also prepared a simplified view just to better understand. You have a series of requests. So you have 2 passengers that requests. So it's like something like on their smartphone at 3 p.m. and 3 minutes, they select the desired time, that is 13 minutes past 16. And they are 2, and they want to go from these 2 nodes. And you can see also on the map what is the starting point and the destination point. So for each trip request, you can see the starting point and the destination point. Now, please, let's remember this straight line, because later on we will see what happened with the tour planning. So how this straight line transforms. And there is, before going into the tour planning procedure, there is something really, really important I wanted to show you. That is, if you have a DRT service containing that is already capable of giving you the trip requests, such as I simulate here, you can just copy and paste the trip request of your DRT system in Visum, because as you know, the white cells in Visum are editable, so I can just copy and paste the attribute in this way. So you don't even need to spend time on metrics and node to zone allocation. So if you have a DRT service that is capable of providing you the trip request, you only need to allocate the address to the nodes of the Visum model. And then the job is done. You have the trip request, and it's the best you can do, because it's actually, you're actually simulating with real-time data. So you are importing real-time data into your model, and it's the best you can do. Let's move on the tour planning. So this is really the core of the presentation. So it's a simulation procedure. And here you have to define the demand period. So I want the service to run between 10 and 20. So, but be careful, because here there is a suggestion. The demand period refers to the beginning of the work link to the pickup node. That means that I cannot set the demand period exactly equal to the generation of trip requests, because the user needs time to reach the stop point. So I have to use a buffer for the users to reach the stop point. And that's the reason why in the project we set a buffer of 30 minutes that more or less is sufficient to reach every stop of the network. Then you have to save where you want to save the results. Here I set 2, but you can also generate a new one. You can see 3 appears. It's just a path set. So the results are written into a path set. You can select an UDA to store the results of the link. So how many DRT vehicles I have on a link. And then let's see really the most important parameters, that is the fleet. And here is exactly where we realized that the number of 2 vehicles was not enough. So we started simulating with 2, but 2 was not enough. So then we tried with 3, and the satisfaction rate was 100%. So we are working with minibus. So we have now 3 vehicles with 20 seats. And then you have this window of vehicle sharing, where really actually a bit tricky to understand. So let's just, I prepare a slide to explain the factors you consider. So in that window, you have, I hope you have Visum, so you can keep looking at that window. In the meantime, what is very, very important for the tour planning is the maximum arrival rate. So the tour planning runs, and it does want to optimize the arrival time. So it does want that all the user of the network arrives before the arrival time that for them is acceptable. And what is the formula for the maximum arrival time? Is equal to the departure time, that is the departure time in the trip request, the ideal travel time, so the travel time that it will take the bus to go directly to the final stop point. And then there is this this term that refers to a quantity of time that the user can accept once is on board, and is given by the usage of the maximum detour factor that specify the factor for the maximum additional time accepted by passenger to serve more than 1 trip request. So if there is a deviation to serve 1 trip request, I can still accept some delays, and I can set it with this detour factor. The maximum detour time, that has basically the same meaning but expressed in minutes. So it's the time accepted by passenger that results from services from more than 1 trip request. So they're basically the same thing, but once is a factor for the ideal travel time, this one is in minutes. And then there is the detour time accepted detour time. That means I want to use a DRT service. At the moment I decide I use the DRT service, I always accept at least 5 minutes of delay. This is what everyone does when dropping off a bus. So you know that there will be a small delay, and you know you want to accept it. And then there is the maximum wait time. So the maximum duration passenger must wait for the arrival for an arriving vehicles. So this is an example. Let's suppose the departure time is 10:45, and the ideal travel time from stop to stop is 6 minutes. So you have the departure time plus the ideal travel time plus the minimum between the maximum of 6 minutes and 12 minutes, that is the detour time accepted at all times, and 16 minutes. So the final result is 11 and 3 minutes. Again, then here the question could be, okay, but how can I set these parameters with surveys? Surveys. So how many trip requests you can accept during your route? How much delay you can accept? What is the maximum detour you can accept? That is, after many surveys, you can see that more or less there are the same numbers, and you can put the number here. So let's use the number we have just seen. Yes. And here is the option that allows you to define which are the PUDO points. So basically filter the PUDO points, permit only active nodes as PUDO points. So once you filter nodes having PUDO equal to 1, then you have the PUDO points. And here you can select the maximum work time to the stop point. If there is a maximum of pickup or drop-off points per each node, if there are some nodes which you can use only for pickup or only for drop-off points, and the time for boarding and alighting that I set as 8 seconds. Number 2, the tour planning. This is the objective function that is behind the DRT simulation. So in here you can basically select if you want to have more served trip requests or fewer vehicles. That means that if I move the objective function to the left, I maybe have all the trip requests satisfied, but I have less vehicles. And the opposite is here, of course. I recommend you to use the tour optimization interval that basically says I put the requests in chronological order. I want to satisfy the first 100 requests, and then you can satisfy the other. And finally, the cost. So this is the cost function, and you can decide which are the weights that you want to give to run and wait time of vehicles and to the passenger work time. So maybe for you, it's important that people does not walk too much to the destination, to the stop point. You can lower this one, or on the opposite, you can increase it. And finally, you can you have to select the attributes for taking the link run times. So in this case, minibus. And that's the reason why in the beginning of the presentation, I told you, remember why we defined the demand segment. I'll go quick on this tab as we have just few minutes. This one is very easy to be understood. Here you have to select which is the UDA for the holding area. We define the UDA for the holding area. And you can define if the start and the end of a tour is from the holding area, and if you want to use the holding area for the relocation. So after 15 minutes of inactivity, the bus goes into the holding area. And that's basically everything. So this is how to set up the tour planning procedure. We can move on to the results I have already prepared for you, fortunately. So what are the output? We can see the output here with this layout file. So you remember before in the trip request, there was a straight line from point to point. Now, if you select the trip request, you can see there is a trip. So this is the trip that was made to satisfy this trip request. Moreover, you have the bus number. So this is bus number 2. How many passengers were carried over this route? The desired departure time and what was the real departure time, and what was the arrival time. So this was actually a perfect trip, and in fact you can see the tour factor is 1, because the DRT ideal travel time was 5 minutes, while the DRT right time is exactly the same. You can see, for example, this one, when there is a small deviation, really small deviation. So these two passengers took the bus number 2. They wanted to start the trip at 5 p.m. 20, but they actually started 9 minutes later. So there was a bit of a delay. And there is also, yes, you can see here there is a big detour because probably this bus took other passengers. And in fact, the runtime, the ideal runtime was 4 minutes, but the real runtime was 7 minutes. And there was also a small delay in the departure time. That one, the departure at 1 minute past midday, the departure at 13 minutes. You can also see the route of the bus. So if, for example, I select bus number 3, I can see the bus number 3 start from the station, and then you can see the red arrow here. It moves and it collects 3 passengers. So there are 6 passengers on board, and it moves along the city of the town with 6 passengers on board, and all the 6 passengers alight at the same stop here, and then the bus go back empty actually to collect other people. Let's see here, it collects other people at the hospital, so 3 people at the hospital, and carry these people. So actually here you can also add the kilometers, everything. You can calculate the service kilometer, the passenger kilometer, everything you can calculate from here, and it's very, very efficient to see the routes of the bus and to understand what the tour planning is doing. So you're actually simulating the client to let him a bus traveling. How many people analyze. So I selected only the main ones, but of course you can do all the analysis that you typically do for public transport can be done for the tour planning assignment. And so I guess it's done. We have just 2 minutes for the questions, but actually we have 2 minutes, but you can see here my email. So if you have any technical question about what we have seen, you can write me if there is no time. While for all the commercial inquiries, you can ask Francesco Oliviero.
Yes, thank you. Thank you, Mariano. Yeah, we have just a couple of minutes because unfortunately we have just this lot allocated for the webinar, so we cannot go. We cannot use the next lot. But if there are questions, maybe you can write it down right now in the slot. And if not, so if, as Mariano said, if you have questions after the end of the webinar, maybe watching the recording, you have questions, you can reach us at these 2 email addresses. So let's wait just a minute, and then if not, if there are no further questions, maybe let's end the webinar. In the meantime, let me just say that we will have another webinar in March for sure about PTV lines, which is one of our SaaS products. Probably at the end of March. I'm not sure about the date yet, so you can follow. You can just check your emails for the invite that we will send you. Okay, so I don't see questions. So thanks for joining us today. Thanks for watching the webinar. Thank you, Mariano, and we'll see you at the next webinar. Thank you very much.
Thank you.
Bye, everyone.
Bye.